All right, so we're moving right along. Now we're going to identify geometric sequences and the characteristic of a geometric sequence. Whereas an arithmetic sequence, we have a common difference that we can add to each successive number. In a geometric sequence, we have a common ratio that we can multiply by each successive number. Now, before we get into that, let's think about what's a ratio. Well, if I've got a number 4, 4 is actually a ratio. It's 4 over 1. And of course, the inverse of that is 1/4, also a ratio, 1 over 4. Now, if I'm going to determine and try to identify a common ratio, what I want to do is take what would be A2, or the second number in the sequence, and divide it by A1, the first number in the sequence, and then continue doing that taking the next number and dividing it by the previous number. So let's take a look at the sequence we got right here. We got -8, we got 2, we got -0.5, and we got 0.125. Well, I can pretty well establish right off the bat this is not an arithmetic sequence, because the difference between -8 and 2 is 10, and obviously 2 plus 10 does not equal -0.5. Now, another thing that I can kind of identify as I'm proceeding now, okay, well, it's not arithmetic, is it geometric? The fact that I've got a -8 and then a 2, and then the 2 followed by a -0.5 is telling me that if it is a geometric sequence, my common ratio is going to be a negative number, because negative times a negative right there is going to give me a positive, and a positive times a negative is going to give me the negative, and the negative times a negative is going to give me another positive. So I can pretty well determine I'm looking at least a negative common ratio. Now let's take 2 and divide it by -8. Well, that's going to come to -1/4 if I reduce that down. And if I were to take 2 and multiply it by -1/4, I'm going to discover that that's going to be -0.5. And thirdly, if I put into the calculator positive 0.125 divided by -0.5, well, then I'm going to determine, see there again, that my common ratio is -1/4. So my common ratio is -1/4. And so, yes, this is a geometric sequence. Let's take a look at another one as we're trying to identify geometric sequences. Before I move, if you're doing this on a calculator and you're having to deal with fractions, in this case we had decimals, but if you're having to deal with fractions, put those fractions in parentheses before you do your division. That will help to ensure that you're getting a correct answer and not a false answer. Sometimes your calculator will not pick up those fractions where you're dividing a fraction by a fraction properly. And the best way to ensure that you've got that in the proper form is to put those fractions in your calculator inside parentheses. Okay, well, let's look at this next sequence to see if we can determine whether we've got a geometric sequence or not. And so in our sequence, we've got 1, 3, 7, and 15. All right, so the difference, if I'm thinking about whether it's an arithmetic sequence, the difference between 3 and 1 is 2, but 3 plus 2 does not equal 7, it equals 5. So it's not an arithmetic sequence. What about if it's a geometric sequence? So let's see, I'm going to take my A2 position, which is 3. I'm going to divide it by the A1 position, that's 1. That means I got a common ratio of 3. And if I were to multiply, well, let's just take it this step. If I take 7 and divide it by 3, well, that's not going to equal 3. In fact, it's going to equal 2.33 repeating. So this particular one is not an arithmetic sequence. It's not a geometric sequence. It is a big neither. And it's neither because it does not have a common difference and it does not have a common ratio. Now, kind of lucked out on this because my actual third term told me that it was neither common difference or a common ratio, not an arithmetic, not a geometric. But you got to be careful because sometimes just don't do 1 or 2. Go ahead and finish out your sequence until you disprove that it's arithmetic or geometric, because sometimes they'll trick you and it'll be this number right here that blows it. So don't get in too big a hurry. And you won't, because this is just so much fun. I'm telling you, how can it get better than this?